Welcome back, everyone. Today what we're going to be doing is discussing domain and range. By the end of these lessons, these series of lessons, you're going to be able to determine what the domain is of a relation, what the range is of a relation, and write in set and interval notations those domains and ranges. All right, so you ready? Here we go. So the first thing you need to know is a relation. Relation, as we described before, is a set of points which have two variables. Okay, it connects the two variables. For instance, your x variable and your y variable. So the easiest way to describe a relation is with the xy coordinate plane. Now, on that plane, you have two things. You have your domain and you have your range. The domain is the set of all types of values which the variable on the blank can take. What? Set of values which the variable on the blank blank can take. So what do you think? Domain is what? The horizontal axis. Okay? So this is your domain, this axis. The variable is usually, what variable is usually the horizontal? Is usually an x. Okay? So your domain is down here. Your domain is left to right, right to left. Your range is the set of values which the variable on the horizontal, the opposite of horizontal, which is the vertical axis. Okay, the vertical axis is the up and down axes. Okay, that variable is usually the y. All right, so there's your range. So the domain is the compilation of all your x values, and the range is all the possible y values for your relation. Okay, so in this case, this is the lowest possible piece of the range. This is the highest. This is your range. This is the smallest, the least amount of value your x value has. The highest amount, so this is your domain. All right? Now, the domain and range of a relationship can be described using a couple different things. The ones we're going to focus on are set notation, interval notation, or a number line graph. Now, all three of these describe the same thing, and they all pertain to one meaning. So I'm going to show you the first one, then let you guys try the second one. So this says the set of all x such that x is greater than or equal to 3. So when you use set notation, what you want to do is the set of all x. So this is telling you you're dealing with your x set. Now the second thing it says is greater than or equal to 3. So in this set of x's, x is greater than or equal to 3. And that's what set notation is. Interval notation, okay? That one, you don't need to put what the set is. You don't have to say it's all the set of x's. You would just put x is greater than or equal to 3. That's the one that you guys have been using most of your lives, all right? You can also write that as a bracket, 3, comma, to infinity, which we will get to as we get to calculus later on. And now the third type is with a number line graph. Now, since x is greater than or equal to, you would use a closed circle because it's equal to, closed circle, remember, is equal to. Open circle is up to but not included. And because it's greater than, it's all the values above. This value right here runs to infinity. This one goes to negative infinity. So since it's greater than, it's all the numbers greater than 3. All right, so why don't you guys attempt the next one, the set of all x such that x is less than 2. So let's see if you can write it in both methods. All right, let's see. Set of all x, so you're going to do your set of x, and x is less than 2. Less than or equal to as the line under it, less than does not. Interval notation, you just need the second part, which says x is less than 2. To write this on the graph, you go to 2, you do not a closed circle, but an open circle, and every value to the left. So this is every value to the left of 2, up to but not including 2. Okay, why don't you guys try the next one? The set of all x's, such that x is between negative 2 and 1, and it includes 1. What do you think? So once again, you're going to have your x. X is between, it's greater than, wherever you have the open mouth, that's greater than, negative 2, and it's less than or equal to 1, because between the two it includes 1, so that means it's also equal to 1. Interval notation, x is greater than negative 2 and less than or equal to 1. And then your number line graph, okay, greater than negative 2, so that's an open circle, less than or equal to 1, that's a closed circle, and it's everything between the two. There you go. That's it. Fairly simple, isn't it? Last one, the set of all x such that x is less than or equal to 0, or it's greater than 4. So now you have an or. Do you remember this? This is all stuff we've done. Not us, but so, set of all x is less than or equal to 0, or x is greater than 4. Okay? Interval notation, you just write it without telling you what set it is. And then the number line graph, because it's an or, that means both things are true. They don't have to both be true at the same time, though, so it's not overlapping. So it's like a split graph. So x is less than or equal to 0, so it's a closed circle, and you go to the left, and it's greater than 4, open circle here, and you go to the right. And there you go. 3 different ways to write 4 different equations. Right? Not too terrible yet, right? Don't worry, we're just getting started. To find the domain and range of a function, we could observe its graph. Okay? Now, considering the opening problem from the start of chapter 3, right? We're still in chapter 3? Yeah. What it said was, that was the car park. So consider again the car park charges in the opening problem. So the function is defined for all time t such that t is between 0 and 24. It doesn't include 0, but it is less than or equal to 24. Therefore, what's the domain? So here's your problem right here from the original problem. Now you notice these open circles here. That means these points are included. You notice the closed circles. That means those points are included. So what's our domain? Our domain is our x value. So what's the smallest number this could be? 0. Does it include 0? No. Does it include 24? Yes. So the way you could write this is...
Mr. Papa, please report to the secretary's office.
From 0, this should be an open circle right here. I don't know, it's filled in. All right. To 24. So your domain is, t is the set, right? So we're doing this is set domain. So you're dealing with the set of t. T is greater than 0, and that's equal to 24. This is interval notation. This is set notation. All right? For the possible charges, there is L, so that's pounds. 5 pounds, 9 pounds, 11 pounds, 13 pounds, 18 pounds, 22 pounds, 28. What is the range? So these are all the different types of charges you could have. So the range is just each one of these. It's nothing between here. You can't charge between these values. You can only be charged these values. So you would just use the bracket with this thing. I forget what that type of bracket's called. It's a type of bracket. And you just write down all the numbers. And you just put commas between them to show that it's all true. So that means that each one of these is a possible value. However, nothing between them is a possible value. Right? Number 2. Why don't you guys look at this? All the values of x is greater than 1 are included. So what is the domain here? Why don't you guys think real tough? How would you write the domain? You got your answer? And I want you to write in set notation. So the domain is including -1 is all the values greater than. So it's the set of x is greater than or equal to -1. All right? All the values of y is greater than or equal to -3. So look at y includes -3 and it's bigger than that. So your set is not of x but of y, and y is greater than or equal to -3. Problem number 3. This is a good introduction for all this stuff. X can take any value. Okay? So the domain is, what happens when the x can take any value? So look at these arrows, when it goes like this forever, and it goes like this forever. So it is everything from -infinity to infinity. How do you think you could write that? Well, you would just say x e. What does that mean? This means x is the set of all real numbers. All real numbers is any possible number. And another way to write it is without the brackets. So you don't even need the brackets when you do the x is the sum of all real numbers. All right, the set of all real numbers. Now in this case, y cannot be 1. So x is, okay, x can be any real number. Right? Y here, our y values cannot be what then 1? It's from 1 and it's everything under 1, right? So y cannot be greater than 1. So what's the range? The range is everything besides stuff greater than 1. So it's from 1 down. So it's all the values that are less than or equal to 1. All right, and remember you're dealing with the set of y. Now when you're dealing with all real numbers, you don't have to do x. X is the set of all real numbers. So you can just do x is the sum of all real numbers. All right. Try problem 4. In problem 4, x can take all values but, oh, we have an asymptote here. So what value can x be? There's the asymptote, it's at -2. So it's it's at 2. So it's every value except 2. So how can you write the domain? What do you think? Okay, give me an answer, let's see. So it's going to be x, the set of x, right? X is not equal to 2. Okay, or just x is not equal to 2 if you use interval notation. You can also write it as x is less than 2 or x is greater than 2. That's also permitted. In this case, this is a lot easier though. Y is all the values but, what is y not here? There's my asymptote right here. Y is every value but what's in the asymptote because it approaches it from the top here, approaches it from the bottom. Can't cross asymptotes. Every value except for 1. So the range is, you got it, y is the set of y can't equal 1, or y just does not equal 1. And once again, set notation, interval notation. Now you ready to do some problems on your own? Almost? Let's get done with, let's do all the lesson stuff first, then we'll do the examples. Alright, so the next fun thing, and then we'll get into examples right after this. To fully describe a function, we need 2 things. You need one, you need a rule, and then the second thing is you need a domain. Okay, so what exactly does that mean? You need a rule and a domain. So first off, sometimes you're dealing with something called a natural domain. Alright? If the domain, so that's the largest part of all real numbers for which f of x is defined. Now in this case, it's used if the domain is not specified. Okay, so if you're not given a domain, you use the natural domain. Okay? So you're just assuming it is going to be the largest value. Alright? Now, you can click on this icon, and this icon is on page 54 in your book. And on this icon, you can use the software to find the domain of range, a ton of different functions, okay? Right now, let's look at this stuff. So, here's some examples that are shown in the table opposite. So, natural domain. What are the values I can plug in for x here to make that value to not get undefined as a value? Well, I can plug in any number I want into there, because any number squared gives me an answer, right? What about here when I'm dealing with the square root? Can I plug in any number and not get undefined? No. What is, I'm going to call it bad. What can't you have under a radical? This is the most important table with domain too, by the way. You can't have a negative under a radical. So that means under the radical is everything but a negative, which is 0 and positive numbers. So x has to be greater than or equal to 0. So anytime you have a radical, whatever is under this radical has to be greater than or equal to 0. That's how the domain works. Now when you deal with a fraction, what is true about the denominator of the fraction? This cannot equal what? Cannot equal 0. So the denominator of a fraction cannot equal 0. So if you're finding the domain of a fraction, you would set it equal to 0, you'd solve for whatever is under here, and then you would say that's what the problem can't be. Now, tricky. We're going to combine these two. What if you have a number, a fraction, with a variable inside a radical? Both of these things are true. So first off, this whole thing can't be 0, and under the radical can't be negative. So since it can't be negative and it can't be 0, it has to be positive. And all positive numbers are not greater than or equal to 0, but just greater than 0. Okay, so those are the four situations, the four main situations you will be dealing with natural domain. Okay? Besides that, everything is pretty much cut and dry. Any type of polynomial, you use all real numbers. But when you're doing fractions, you got to make sure the bottom set it equal to 0. That's where it's not allowed to be. And radicals, you cannot have negative sign radicals. We do not deal with the imaginary numbers, so don't even bring it up. All right, but like I said, click on that, play around a little bit, and now we're going to do some examples. For each of the following graphs, find the domain and find the range. So, go. Domain, left to right, left to right. All right, you should have done this example. The domain is all the numbers from here, because this goes like this forever. All right, and it goes up to that number. Now this is the x value, the y value. X value is 8. So that means 8 is the largest number it can be, and it's every number less than 8. But it also includes 8 because that's a closed circle. So it's the set of x is less than or equal to 8. Now dealing with the range, okay? So this goes up to infinity. So the highest number is infinity. And this doesn't matter, just the lowest matters and the highest matters. So see this 4, 3? Doesn't mean anything yet. So we go down to 8, -2. This is -2, so that's our lowest value. So all the values have to be above it, higher than -2 or equal to -2. So the range here is y, the set of y's. Y is greater than or equal to -2. All right. Try B. Oh, B is an easy one. All right. The domain, forever, forever, so it is all real numbers. All right, the range, well, it goes up forever, so it's going to be greater than something. The lowest value is right here, -1. So it's the set of y's. Y has to be greater than or equal to -1. That's it. Not too tough, right? Graphing domain and range is easy. It's the other stuff that's annoying. All right, so let's look at exercise 3. See, there's a bunch of exercises here. We're going to participate. So first one, a driver who exceeds the speed limit receives demerit points as shown in the table. Okay, so here's his table. Draw a graph to display the information. All right. Ready? So, hopefully you did that. Then we're going to find the domain and range. When x is between 0 and 10, you get 2 demerit points. So you go up to 2, between 0 and 10. Now it's not equal to both of these, so it's not equal means open circle. So open circle from 0, open circle on 10, and you have a line connecting. All right, now if you didn't get this, now use this to do the other ones. Give you enough time to do it, okay? 3 demerit points from 10 to 20. Now it includes 10, so that's a closed circle. Doesn't include 20, so that's an open circle. So we go up to 3, closed circle, open circle, and we connect them. That's it. 5 demerit points, 20 including 20, so we go up to 20 including 20, to 5, closed circle, 30, open circle, connect. 7, between 30 and 45. So we go up to 7, closed circle, 45 open circle, connect. And then lastly, if you're greater than 45, you get 9. So, greater than 45 is everything this way and this, and you get 9. Arrow means it goes that way forever, okay? Eventually, you can't go like 1,000 miles over the speed limit, but that says whatever your open speed limit you are, right? That was pretty easy, wasn't it? Now, we're going to use that graph to find the domain. Domain is not including 0. Okay, it includes this one, includes this one, includes this, and includes everything this way. So the domain is from 0 to infinity, not including 0. So it's the value of x, right? The set of x, and it's going to be every number greater than 0. Okay? Not greater than or equal to, just greater. And now the range is just these values. So what are the values? 2, 3, 5, 7, 9. So the set of y equals 2, 3, 5, 7, 9. It's just the y values. 2, 3, 5, 7, 9. That's it. All right, let's move on to problem number 2. This graph shows the temperature. Barcelona. Over a 30-minute period when the wind shifts. So the wind obviously makes the temperature cooler or warmer. All right, so number 1, explain why a temperature graph like this must be a function. Why does this temperature graph have to be a function? This is easy. At any moment in time, there can only be one temperature, so the graph has to be a function. I can't be standing in this room and it being 20 degrees and 40 degrees at the same spot. Yes, it could be 20 degrees over there and 25 degrees by the window, or vice versa, right? However, in the same spot, in the same time, you can't have 2 different temperatures. And temperatures can't like jump between temperatures. They have to rise and fall. They have to be connected, okay? You can't just go from 20 degrees to 40 degrees. You have to rise through all the other degrees first. You may do it quickly, but you have to do it. There's no like instantaneous temperature pop up. Find the domain and range. The domain is the x values. We're going to use the horizontal line test to see if it's a function. Let's look. Let's draw some horizontal lines here. Does it ever intersect the graph more than once? Nope. It is a function. Find the domain and range. Domain is from 0, including 0, up to 30. Including 30, because there's closed circles. So you would say the domain is all the set values of x, where t is greater than or equal to 0 and less than or equal to 30. Right? Range, the up and down values. Now, this gets some people. It doesn't have anything to do with these points. Your range is the lowest value. So the lowest value is right there. That's the lowest point on the graph to the highest point on the graph. The highest point on the graph, we're going to use this right here, is right here. Okay? I'm actually, there we go. There's the highest point. Okay? It has nothing to do with the endpoints. So the lowest point on the graph is at 15. Highest point's at 21. So t, the range is t now. Okay? Not y. All right? And the range here was lowercase t, because t minutes, it's whatever the graph is labeled, not necessarily always x and y. So capital T from 15 to 25. And yes, you have to put the lowest number on the left, the highest number on the right. You have to put the lowest number on the left, the highest number on the right. If you mix them up, you are 100% wrong. You have to say t is greater than or equal to 0. It can't be less than or equal to 0, or the problem is 100% wrong. Got it? Problem number 3. So you're going to find the domain and range of these 9 fun problems. Go. I thought this was a quick lesson. This is a little tricky lesson. About a 3-day lesson probably. All right. Are we ready? Here we go. Letter A. The domain is from here on -1. So equal, greater than or equal to -1. Range is from this number down. Closed circle means it equals, so it is y. And instead of y, y is less than or equal to 3. Alright? Letter B, domain, open circle, closed circle. So it's from 1, it's greater than 1, and it's less than or equal to 5. Remember, x's come first. The range, open circle, closed circle. So it's from 1 to less than or equal to 3. All right? Problem C, we got two asymptotes here. So x can be every number but where the x asymptote is. Every number but 2. X not equal to 2. The range is going to be every value of y, instead of y, every value of y. But what y value? -1. Right, and the blue and the red things just show you the domain range graphic. Alright. Uh-oh, fire zone. D, the domain here. Up, arrow goes forever to the right, ever to the left. That means your domain is all real numbers. And yes, you could put it as the set of x. X is the set of all real numbers. So you could use that or not. It's up to you. The range. Now, look at this. This thing flattens right here about the origin, which is about 0, right? And it goes up to 2. So your range does not include 0 because you never actually hit this line. Even though there's no asymptote there, you can see what's happening. So it's going to be greater than 0 and less than or equal to 2 because that is a closed circle. All right? E. Oh, look at that. All real numbers for your domain. Your range, lowest point is right here, and it's everything above that point, which is -1. So it's a set of y. Y is, whoa, that should say, y is greater than or equal to 1. All right? Whoops. Easy fix. All right, F. Your domain, once again, all real numbers. Parabolas are all real numbers every time. The range, 1/2 is your x value, so we don't care about that. We care about the 6 1/4. So it's going to be 6 1/4 and everything under that. So y is less than or equal to 25/4. 25/4 is the same as 6 1/4. Or you can put less than or equal to 6.25, however you want to do. I couldn't fit 6 1/4 here, so I just went with the next number. All right? Problem G, your domain. Well, it goes forever to the right, but -4 is the smallest value. So it's from every number greater than or equal to -4, the set of x's. Now y, you have to figure out what the lowest value is. Y goes up forever. Okay, so it's going to be something greater than or equal to. And when I check out my lowest point, it's right here, -3. So y is greater than or equal to, whoops, -3. All right? H. All the way to the left, all the way to the right. Domain is all real numbers. Now y equals -2. This graph kind of goes right there. Hugs the asymptote. So it gets as close as it can to -2 without touching it. So it is greater than or equal, just greater than -2. All right? There you go.
Thank you. This one's heavy and hard.
It is. Good luck. Any questions?
I have a lot.
All right, we'll go on the WebEx after school. I'll get you. All right, just send a reminder. I'll help you. Or not. All right. The way I works. Your domain is every number but -2 and 2. So what you do here is you have domain is all values of x not equal to, you can just put a plus minus 2. But it's not equal to -2 and it's not equal to +2. Alright? What is your range? Now this is a little tricky. Your range is, this says right here at -1, it tells you this point. So it's all values of -1 and lower. So that's y is less than or equal to -1. And then it's also all values that is greater than 0. So your range is the set of y. y is less than or equal to negative 1, which is right here, and y is greater than 0. All right? That's all you have to deal with. Got it? A lot of work, seems like a lot, but it's really not that bad. Let me step out so you can take it all in. I'm not in your way. And let's go to some more problems. Problem number 4. Consider the graph. This is a nice little piecewise equation, which we will be doing in chapter 4. We're going to learn how to draw these things and master this stuff. Consider the graph of y equals f of x alongside. Alongside means right there. Decide whether each statement is true or false. So first off, let's find the domain and range of this graph. Go. All right, did you go? Range. Smallest, largest. So it goes from -7 to 5, right? Set of all x's, x is greater than or equal to -7, x is less than 5. Range. Lowest number. Highest number. So it's from, what number is that? 3 to 10. Y is greater than or equal to, I should say 3. Y is greater than or equal to 3, and y is less than or equal to 10. All right? Next one, because it's 2 is my x value, 2 over 3. All right? All right, so is -5 in the domain of f? Well, let's see. -5 is where? About right here. Does that fall in your domain? Yeah, it's on your graph. So that is true. Because if I wanted to see, -5 is like right here on my graph. There's an x value, or there's a y value. Is 2 in the range of f? So now we're dealing with the y's. Ranges are y's. What do you think? 2 would be down here. So 2 is like right here. Is there any 2's on this graph? Does the graph ever cross 2? No. So that is false. Is 9 in the range of f? Well, let's look. 9 is right here. So if I looked over here, oh, look it. There's 9. It's on my graph. Is in the range. That is true. Is radical 2 in the domain? Now, radical 2, for those of you guys don't know, is 1.41. All right? So let's look. Radical 2, 1.41 between those two. So about like right here. That is indeed on our graph. That is true. All right? Any questions with number 4? No? Awesome. Now we're going to move on to number 5, example 5. This is the part that's really bad. When I teach calculus class, this is one that a lot of students mess up. This is solving this stuff analytically. So, number 1, state the domain and range of the following functions. All right? Now, f of x equals the square root of x minus 5. So, the way to find this domain, think back of when I taught you guys about the natural domain. So, in a square root, what do we know? We know that there can't be a negative number under a square root. Our answer is undefined. So, in order for this to be positive, the x minus 5 has to be greater than 0. And you can also have this be a 0 under here too. So it's greater than or equal to 0. So anytime you have a radical, whatever is under this radical is going to be set to being greater than or equal to 0. And now you solve for x. You're going to add 5 to both sides. Therefore, x has to be greater than 5 or equal to 5. If x is 5, square root of 0 is 0. If x is 6, square root of 1 is 1. Okay, let's pick a number that's not less. Say you pick a number less, 0. 0 minus 5 is negative 5. Square root of negative 5 is, ooh, that's bad. That's wrong. All right? The domain is all the sets of x, okay, which include all the numbers that are greater than or equal to 5. Right? The range. A square root can't be negative, right? So since this can't be negative, that means the lowest answer possible when you're dealing with the square root is what? Well, let's see, if I plug 5 in here, 5 minus 5 is 0, the square root of 0 is 0. So 0 is one of our answers. And if I plug any number greater than 5, this answer does what? It gets higher and higher and higher. So this can't be negative ever, because there can't be a negative under it. So it's every answer that is 0 and above 0. So the range, when you have a radical, is always going to be y is greater than or equal to 0. Okay, as long as nothing is attached to this radical, and it's just a radical by itself, the range is always going to be greater than or equal to 0. All right? Fraction. What do we say about the fraction? The denominator of a fraction cannot equal... Oh, here. Here's what the graph would look like. It would actually look like it starts at 5, and it's like the square roots always are in the first quadrant, and they always kind of look like a half problem. Right? Problem B. Can't equal 0. You can't have a number over 0. Always undefined. So, I just set this equal to 0. X minus 5 can't be 0. What do I do to both sides? Add 5. Therefore, x can't be 5. So the domain is the set of all x's, but x cannot equal 5. Now the range. Here's the tricky thing about the range. If you just have a number on top of here, no matter what I put in for x, what will my answer never be? Because there is no variable in the numerator. F of x will never be 0. Pick any number in the world. 5 makes it undefined, so you can't pick that. You need to set the numerator equal to 0 for my answer to be 0. And 1 will never, ever, 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 ever equal 0. 10 will never, ever, ever equal 0. So unless 0 is in your numerator, any other number by itself with no variables attached to it can never be 0. So the range is set of all y's where y can't be 0. So that means that there is going to be an asymptote at 5 for my x's, and an asymptote at 0 for my y's. Okay. Last one, radical in a fraction. So what do we do for this one? Radical in a fraction. First thing, can't be 0, can't be negative, so it's not going to be greater than or equal to 0, it's just going to be greater than 0. So that means x minus 5 right down here has to be greater than 0. Solve for x, you're going to add 5 to both sides, so therefore x is greater than 5. The domain is the set of all x's where x is greater than 5. Now, what can't this be? Can't be negative because there's a square root. Can't be 0 because there's a number on top, so therefore the range must be positive and can't be 0. So x is going to be close to this. It's a combination of these two. Greater than 0 but not 0, so x or y is going to be greater than 0. Okay? And if you want to look at the graph, it looks something like, whoops, that little thing. Right? It's like half of that. Got it? We're almost done. 2 more sets of problems. So, problem number 1. Look at that problem. Without graphing it, I want you to state the domain. All right. What'd you get? It's an easy one. Radical. Radicals can have negatives under it. So, x has to be greater than or equal to 0. There's your domain. Set of all x's where x is greater than or equal to 0. Copy and complete this table of values. So now you're going to take all these x's, plug them into this equation. All right. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9, 3. Square root of 16, 4. Sketch them all. Plug them all. All right, let's see. This is your x, this is your y, so 0, 0. 1, 1. 4, 2, so 4 over, 2 up. 3, 9. Sorry, 9, 3. 9 over, 3 up. These go by 2s here, these go by 1s, just so you know about my scale. 16 over, 4 up. Connect them, and that's what your graph looks like. That is the square root graph. Find the range. What's the range? Well, first of all, we said before, under a radical can never be negative, or you can just look right here. Square root cannot be negative. Y, instead of all y's, y is greater than or equal to 0. Looking at my graph, 0, everything above 0. Look at it over here, x includes 0, everything above 0. Okay, so you just did this problem graphically and numerically. These are easy though. I gotta break it. Oh, here we go. Here comes fun ones. We're gonna finish it off with some nice, tough problems. And if you need extra problems, I have plenty of problems. I do a whole lesson on this in calculus. You can actually download and go to YouTube and check out my domain range lesson. I spend about 2 weeks of normal class time focusing just on domain and range. Well, actually a week. It's entailed with another pre-calc lesson. All right, so let us go. Letter A, state the domain. Radical. Okay, so first thing I go, okay, square roots. Can't be negative under square roots. So x plus 6 has to be greater than or equal to 0. Subtract 6 from both sides. Therefore, x is greater than or equal to 6. The domain is the set of all x's where x is greater than or equal to 6. Negative 6, sorry. Now, we also said this will never be negative because it's under a radical. The range is all values of y where y is greater than or equal to 0. All right? You guys are smart. You should pick this up like that, nice and clever. B. Denominator can't be 0, right? X squared cannot be 0, so x cannot be 0. Domain is the set of all x's where x can't be 0. There is no variable on top, so set of all y's where y can't be 0. All right? Now, why can't this be negative either? I lied to you. Can't be negative because anytime any number I square always becomes what? Positive. If I make this -1, -1 squared is 1. Square that is positive. Everything is indeed positive. All right. Sign your name. Real quick. Write down number 2. All right, sign your name for her too. You could be 2, she could be 4. All right, I'll be there 1 second. She did. All right, you got her. Tell me when you're done. Since bottom equals 0, I'm making one of your nice lessons right here. Subtract 1 from both sides, you get x is not equal to 1. Therefore, your domain is all sets of x where x doesn't equal 1. All right? Range. The top has no variables attached. Therefore, never be 0. The range is not equal to 0. Good? Just, yeah, you can sign for her. That's not good. All right. Radical on bottom can't be 0 because it's on bottom. Radical can't be negative, so therefore x has to be greater than 0. X is the value of all values of x, x is greater than 0. If this was x plus 1, you put x plus 1 is greater than 0, and you would solve, but it's just actually the x. F of x will never be 0 or positive. Normally you would say 0 negative. This number here is always going to be positive. Positive over positive is always a positive. That negative out front changes everything to negative though. Therefore, negative sign, and you get greater than 0. Year 2, you could be number 5. You're welcome. Yep. There you go. Alright. Now the calculator, I'm just giving away some free calculators. 1 over 3 minus x, you set your 3 minus x equal to 0, because, once again, it is, denominator can't equal 0. You're going to add an x to both sides, or subtract 3 and divide by -1, it doesn't matter. X will never be able to equal 3. Because 3 minus 3 is 0, and you can't be 0. The domain is all values of x, where x can't be 3. Your range, no variable on top, so f of x will never be 0. All sets of y, well, y can't be 0. Ready for the last one? Whew, almost there. Under here, has to be greater than or equal to 0 because it's a radical. You're going to subtract 4 from both sides. Ready? Pay attention here. When you divide by a negative, okay, this sign, your inequality sign, switches. So this is going to go from negative x is greater than or equal to -4 to negative x is less than or equal to +4. So I change, because pretty much what I'm doing is I'm adding an x and I'm adding a 4 to both sides. So now x is less than or equal to 4. So my domain is all values of x, where x is less than or equal to 4. I don't know why that messed up like that. All right, now the range. This can be 0 if x is a 4, but it can never be negative because the answers inside is always positive. So y, instead of all y's, or y is greater than or equal to 0. All right, a little tricky, like I said. You can go to my calc lessons, get tons more of these problems if you really want to get good at them. If not, and you already understand it, you're good. All right, so that was domain and range. We were able to do a couple things: determine the domain and range of the relationship, determine the range of the relationship, and do some interval notations. So hopefully after today's lesson, you guys are really good at this stuff, or at least pretty good, at least better than you were before. And like I said before, this is a difficult lesson, especially the stuff we did with problem number 6. So if you need more problems, come see me. Get you those problems, and I'll go over them with you if you need. Okay? So, till the next time I see you, have a good day.